Alright, this is my Steinel SH4 with the vertical spindle attachment. The mill is half through restoration and needs some more tender love and care. Nevertheless, I will be taking care now of the main bearings of the main spindle here, because they make funny noises when working under load, and I will be showing you how I'm stumbling through the process of changing these three bearings. First of all, I have loosened these two slotted nuts here with this tool here, with this notch wrench, cheap Chinese one. Not perfect, but it works. And I took off the head cover here, and there's a ton of grease in there. Let's see what's underneath there. I guess I will have to remove this slotted nut and this also. Hope two of these notched things that I have bought in a set will do the trick. Let's see how it goes. Same probably here. Yeah, there we go. By the way, in here, in the where the vertical spindle is connected to the head, at the moment there's a plastic gear in, because it was missing with my vertical head attachment, and it was printed from ASA. And looks pretty much like this here, and it's amazing how much load this thing actually is taking. And now the question is how to get the gear off. By the way, these gears are expensive, so I really don't want to lose them. It seems that is the same pitch as is down in here. There it goes. Awesome. Off we go. Good. Put it also aside. How to get off the rest of the stuff. Probably also get the other gear off just to be sure to not damage that one either. Oh, there we go. Off with the other one. Needs cleaning anyway. Okay, I put something here below the spindle because if it drops out, I don't want to, have it falling out of the vertical head here. I looked into the drawing from the manual, and I think it becomes clear that the whole spindle is gonna drop down. I removed this nut and this nut. Here is a roller bearing where it seems that it has a ring here, and the outer ring needs to be positioned 10 millimeter below here, the upper edge. And I think if I move it down, this inner ring will just be left there, and it can just take it out. Here is an axial ball bearing that seems to be tightened with a nut. I don't know if I can drive this out or not, but I think so. And I tried to tap it out, but I didn't want to use too much force. And then I figured if I unscrew this outer here, this one here, this outer big slotted nut, it might, because it is here also above the spindle nose, it might pull down the spindle, and hopefully sufficiently. And this is what I already tried, and it seems to come out. So I will continue doing this now. Yeah, it comes down. Oh, I have to take out the key first. Oh, it's because with the key inside there, I will not be able to pull it through. Yeah. Okay. Now, hopefully, it's starting to come off at the bottom because the vise is, there it goes. Perfect. Very good. Of course it grabs more on this corner here because there it is blank, and with that. It's a little snug, but not too much. Probably I can now use this one, the second one, to drive it down even further. Probably, I have to clean all that anyway. And probably I'll put a second oiler here in for the downwards bearing. Yeah, there we go. Let me grab the camera. Now the inner part of the bearing has dropped together with the spindle, so it seems that the inner ring is being pushed onto the spindle and the outer ring is being pushed into the housing here. That's quite interesting. Okay, go further here. Some gentle taps. Yeah, it's coming. It's coming. And we got the spindle out. Wow. Very, very gently. Very smooth. No big hammering. No crunching. Awesome. Okay, so down here we have a tapered roller bearing. This here is full of grease, is the axial bearing. And up here we see now, I can show you in the camera soon, we now have the outer. I have to see how we get out of here. Let me have a look. Oh, there we go. Okay. So here it is. This is the inner part of the upper roller bearing. That's it, still in there. Let's see how we get it out. And this here tightens up. Oh, it's secured here with a small screw, set screw. That's okay. This can be loosened to. There's some play. Okay, seems to be. Okay, this sets the inner ring, and this goes against the housing. And then down here, this is the tapered bearing that is taking the main load and is then with this nut here brought up to tighten this thing here and to reduce the play. So I'm gonna need to remove this ring first. I will try to push it up, probably clean it first, then loosen this, take the axial bearing out, and then we see what we can do to this bearing here, how this goes off. So let's have a look inside. See, here's the roller bearing, and let me get some light in there. There's not much to see. There's a screw that is holding the sister gear of the one that is missing, that I've printed in ABS, and there are two funny dents down there in the bottom. I don't know what that is. Can feel nothing outside. Interesting. All right. Looks good inside there. Seems interesting that we have here an oiler, which actually seems to have been used to put grease in. I will do a little research on that, because I don't know if grease is right here or if oil should be better. Same down here. I have on the drawing that I just have shown you on the front page. You have also an oiler here for this set of bearings. But these oilers are also often used for grease, so maybe in this case it's a greaser and not an oiler, but I will do some research on that. And I'm not sure if I'm gonna pull apart this area here too. Probably I'll take off the cap here to have a look inside, but so far I'm really happy that the spindle came out so smoothly and without any situation where you have where you risk, or where it feels funny that you tap too hard, that you somehow force it out. It was really smooth. Pull it out here with these nuts, very gentle, very evenly, and then it was just some light taps on the top. And I hope that it goes back in like this, because I probably can use the table to bring it up at least until these nuts here grab, and then just screw it in. That might be a good way to do it. Now, one interesting thing that I just saw, now with the nuts removed, you can see that this ring here is actually bolted into the housing. So I would be probably a good idea to take it apart and clean it, and then put it back in, probably also using the table to press it back in and then screw it back in. Let's see how that goes. Let's give it some small positioning mark. Let's mark the one that is here to the oiler, just with one. Let me see. Yeah, probably a little very light. That should do it. That's cool how easy that thing comes apart. I've not thought that it would be so freaking simple to get this thing apart, but it's really, working on this machine, it's really seeing how genius and high precision it actually was built back these days. I was actually told that these machines were used by the German forces in their shops to, you know, keep their stuff in shape and do repairs. And well, I can totally understand. I mean, it's the machine is not perfect because it has no quill, and from the Z height, it is not, you know, it's not a world. But from a quality perspective, I really think this machine is really well made, and you know, doing a restoration on this thing is really, wow, is really a big pleasure, because it is so well made that everything that you pull apart looks really beautifully made. I mean, even this here is ground, this surface, this one also. Wow, that's super cool. Let's see how we get the upper bearing out. So after a quick tour through the trash bin, so to say, I found something that I manufactured some time ago, and I'm trying to, you know, build something up on top that can, oh, that's perfect, that's perfect. There we go. Oh, it already moves. Very gentle. Yeah. Let's see how we get the other one in, right? Yeah, there we go. But it's actually nice to have this head still mounted to the machine. It's quite nice to work with it in this way. Let me try to bring something else in between there. See what we got in the trash bin. Very smooth. Let me bring the camera in a little and you can see that. That's so satisfying to see how controlled the bearing is coming out. So this is why I never throw away any of the stuff that I've built, because these two discs are just perfect for the job, and I did not have to build them because they were just sitting, you know, over there in the scrap bin. There we go. I guess the bearing that I just built this disc and the other thing for was actually also 60 millimeters in diameter, so yeah, that's all out. So do this away, put this away. There we go. That was a piece of cake. I thought that this would be a lot more terrible work building stuff and so on, but it turns out it was actually a lucky catch to have this laying around. Now I will probably get this thing off, clean it, and I don't know if what I will not do is, here is a bevel gear in, and this has to be adjusted in terms of the two positions of the bevels, and this I will not remove, and because then I have to readjust it all. I will not do that. I will probably get a look into this bearing up here and try to get on another look on the big gear. That is on the sister gear that sits here on top and goes in here with the bevel, goes then up to this thing and transfers then to the main spindle. We'll have a look at this and probably also have a look at the bearing and of the gear here, but I leave the bevel, I guess, untouched. So let's take this off. Just for kicks, I just unscrewed these screws, these 3 screws. They were, yeah, sort of tight. And in here are some set screws that actually are being used to, can be used to bring out this ring. And I mean, this is a very tiny screwdriver, and it is so smooth and well made that it already comes out, and no big effort is needed to just, wow, bring the ring up. Well, after having looked into the manual and into the drawing, actually the manual says that these 3 set screws, together with these 3, these are actually draw and push screws, as they are called in the German manual. They are the ones setting the play here in this spiral bevel gear. And the play is supposed to be brought to 0.02 millimeters at 2,800 RPM. Guess I have to figure out how to do this properly.